in science and technology paradigms. The first EIU Science and Technology Symposium that Dr. Daniels and myself work hard to make it not the first one only, but the first in a series that continues. Maybe we will not be responsible for it later on, but the tradition will go on because science and technology keep going on and keep changing the lives of the world, actually. So may I ask Dr. Daniels to introduce our speakers?
No, you can do the introduction. I just want to welcome everybody here. Thank you for coming. I am very excited about this symposium. It's just wonderful to see the variety and the special topics that are coming up over the course of the next several weeks. And thank you very much, Dr. Augustine, for coming.
My pleasure.
Well, Dr. Augustine is, I mean, they have said jack of all trades, master of none, but he is of all trades and master of all of them. I mean, I've learned that firsthand since I came to Eastern 16 years ago, and he is multi-talented. He can run anything, push anything up to the next level. So it's my pleasure today to introduce him, and he multiplied also. He had other speakers.
Well, it's my pleasure to organize this session, and we're very fortunate here at Eastern Illinois University to have faculty here who are well versed in technologies in the field of speech-language pathology and audiology, and I will be forever grateful to my colleagues in my home department for joining me this morning. I'm going to introduce all three of them, and then I'll let them present according to their own, and then I'm going to make them stand with me so I can be among the beautiful people in the picture. So, the first speaker, this is how we've organized it, it might change, but the first speaker is Trina Becker. She is an ASHA certified and Illinois licensed speech-language pathologist and is an associate professor of communication disorders and sciences here at Eastern. She specializes in something called alternative and augmentative communication. And for many of you, you probably are most familiar with this kind of communication through the famous Stephen Hawking, who of course cannot speak on his own and can only speak through augmentative or alternative communication devices. We're really fortunate to have a specialist like that here at Eastern because those folks are hard to find. She teaches our courses in those particular areas, and she also is a clinical supervisor and specializing with AAC. We call that AAC populations. She holds both a Bachelor of Science and Master of Science degrees from Eastern Illinois University. And this is Trina. Dr. Tina McNamara is something that in our profession we call a dually certified professional. That means that she holds certification to practice in both speech-language pathology and audiology. Her professional concentration is in the field of oral rehabilitation, and this is an area where you would be providing therapies for people who have hearing impairment, and so her specialization is in that particular area, and she also focuses heavily on educational audiology, providing those services in our public schools. She's an assistant professor of audiology here at the university, and she's also an educational audiologist and speech-language pathologist with the Special Education Association of Peoria County. She holds a doctorate of audiology from the University of Florida and bachelor and master's degrees in speech and hearing science from Bradley University and a certificate from in speech-language pathology from Illinois State University. And our final speaker will be Dr. Rebecca Thronberg. Many of you probably recognize Becky because she has led a number of initiatives on our campus through CAA and other venues, assessment and such. So she's really well recognized, I think, on our campus. And she's also an associate professor of communication disorders and sciences. She coordinates the departmental honors program and graduate program, and she teaches courses in research methods, communication disorders, language acquisition, and various special topic courses. And she is the co-author, along with Jean Smitley in the department, of a publication called A Sound Start, Phonemic Awareness Lessons for Reading Success. She holds her doctoral degree, master's degree, and undergraduate bachelor's degree from the University of Illinois at Urbana-Champaign. I'm really grateful that my colleagues have come out with me today. I can't imagine what I'll be doing to pay them back for this wonderful contribution to the Science and Technology Symposium, and I'll let them take it from here.
Okay, as Dr. Augustine mentioned, I work primarily with individuals who are nonverbal. So when you're nonverbal and can't communicate through your speech, we have to find alternative methods for communication. So I'm going to talk to you today about AAC, or Augmentative and Alternative Communication. So when I refer to AAC, it can really range from a variety of things. Very, very simple, from gestures to using sign language, all the way up to very sophisticated computerized speaking devices. So I'm going to focus on the big picture technology today and talk a little bit about those sophisticated systems. Anyone who has a significant difficulty communicating can use AAC systems. So some people may have a little bit of speech, but they can't use it functionally to communicate, to those that cannot speak at all. And so they have to find some other way to connect with others, to participate with their family in their education, and relay their thoughts and feelings. So used by people of all ages and disabilities, so you could have a 2-year-old with severe apraxia of speech, meaning they can't produce speech very easily at all, to an adult who has ALS, whose motor abilities are declining over time, then they lose the ability to speak. So from, the little guys all the way up to the geriatric population. Benefits of AAC, well, you can just imagine if you couldn't speak and communicate, and then we give you a way to do so. There are lots of benefits. Obviously, it provides an individual means to communicate. If you're in the school environment, you're able to facilitate learning through those communication systems. Improves language development. It facilitates speech development for some of the children that we give alternative communication devices to, which is kind of something people don't always think about. They think if you give somebody another way to talk, that they won't learn to use their speech mechanism to communicate, and research has proven that that's not true. So for children with apraxia or children with autism, we sometimes see speech develop along with it. It improves self-concept. They have a better feeling about themselves if they can participate, therefore reduces frustration and behaviors that we sometimes see due to not being able to express themselves, and increases their participation in life. There's a wide range of technology when I'm talking about AAC. So we have things that don't use technology at all, that I can use simple pictures to communicate or sign language, or we have some very, very expensive, fancy computer systems to communicate. And I have a little video, I have lots of videos throughout my brief presentation today, but this is one from, his name is Michael Williams, and he is a well-known person in the field of augmentative and alternative communication. He has cerebral palsy. He's a very, very intelligent man. And this little clip is a little part of a big lecture he gives talking about the ways he used to communicate before he had the ability to communicate through a communication system. And he's speaking solely with his communication device, so it's a little bit difficult to understand.
Have I told you yet how I communicated with people during this phase of my life? I learned early on that idle social banter, the verbal caffeine that fuels most societal interactions, was an activity in which I couldn't easily participate. Fleeting social niceties, jokes, slices of juicy gossip always left under my mental carpet, so I could concentrate on conveying what I considered the really important thoughts in my mind. I did this using the most laborious method possible. I drew the letters of each word in the air with my finger, while my would-be linguistic interlocutor winked, blinked, and performed a manner of mental gyrations, trying to figure out what the hell I was saying. My really, really important thoughts were typed on my standard manual typewriter at home, carried to the place of conversation, and presented to my listeners with the greatest solemnity, as if they were the 10 Commandments. Needless to say, with communication methods such as these, one ask your friends.
Okay, so he's talking about when he first started, he was drawing the letters in the air to try to spell things out to other people. And when he wanted to say something really important, he would go home and type it on his manual typewriter and bring it back to somebody and communicate. So communication was definitely not easy for him. The communication device he's using is definitely not the newest and greatest thing out there right now. You can tell that he has pre-programmed those messages, and you can tell just by the words he's choosing as he's communicating. He's a really intelligent man. So that's kind of his progression through AAC, the fact that I'm going to spell things out, I'm going to use my typewriter, and he was literate. So, you know, we have lots of individuals, especially our children, who are not literate. So that was not even a choice for them to be able to communicate. So now we use a variety of systems. A lot of them have voice output, meaning that they speak for that individual. So we have things that are very, very low tech. So I can put 1 or 2 messages on these buttons at a time, and they can communicate very small, simple messages. I have what we call mid-tech systems. So I can put pictures on some of these devices, and I can record speech into them. So when they press the button, it will say what I'm put in that system. But if you had to record every single word into a system, that takes a lot of time. Let alone, this has 20 symbols on it, and an individual needs to say more than 20 things, you know, during any kind of activity. So very, very limiting. But okay to start out with children to get them participating. And then we have high-tech systems. So these are very sophisticated, fancy computers with speech-generating software on them, so that when I press, you know, a symbol, it will the speech will generate from the synthesized speech, just like you heard Michael Williams use. They can use keyboards and spell things out, so that it has text-to-speech capabilities. So my next video is just a video of one of the high-tech devices called the Dynavox, which is a very well-known company. And this video shows all the fantastic things that one of these devices can do for an individual.
When Sarah was first able to communicate, she told me she loved me. Sarah's birth changed all of our lives. She has opened more doors and windows for all of us. Taken us to different places in our life that we probably never would have been.
What's your device singing?
Sarah being nonverbal and having her Dynavox to compose music with and sing with, she was one of the first people to sing the national anthem at 2 Major League Baseball teams at the games. She also got to do the Republican convention. She led the Pledge of Allegiance.
If I did not have the Dynavox, I could not be the artsy-fartsy person I am and write my music, sing, or write my book.
She attends college, answers questions in the classroom, fights with her mom, fights with her dad. Anything with a remote control, infrared remote, the Dynavox can learn the signals, and she's able to turn on her TV, turn on her stereo, turn on lights.
I text message my friends. That is my way, other than email, of communicating with everybody online.
The voice is very human-like. People that have never communicated with Sarah, they understand her immediately.
I would like a tall mocha latte to go.
It just is, it's her life, it's her hands, it's everything. And if we didn't have it, I don't know what we'd do. For those of you considering augmentative communication, follow it and go through with it.
So you can see she had the 2 switches on her wheelchair. That allows her to move the cursors on her screen. So she uses 1 switch on one side to move the cursor as it goes through each symbol, and when she gets to the one that she wants, she then hits the other switch. Because she cannot use her hands to activate the communication system, so we have to find some other way. So again, wonderful technology that allows that to happen for her. So impressive, right? That she can use her device to compose music, to sing, to control her TV with a remote control, to be able to text message, email, get online. They're pretty amazing. So there's a variety of devices out there, and as you know, with everything, things change constantly, so keeping up with those is a challenge. One of the newer technologies is to activate a communication system through eye gaze. So they are now developing communication systems that have cameras on the bottom. So this one has a camera on the bottom, and this one has a camera at the top, and it reads the movement of your retina. So I don't need to control my head at all. All I need to do is to be able to look at the communication system. So I'm looking at a picture that I want to activate or a symbol that I want to activate. I'm holding my gaze on that for whatever specified period of time we can set for that individual, and it can activate it. So this is a little clip of Henry using his eye gaze system Again, you'll see that he doesn't use anything else but looking at the screen.
On August 29, 2002, I suffered a stroke while driving my 4 young kids to school.
And he came in hanging on to the walls in the hallway, could not orientate himself as to how to go to the door. And in the emergency room, I knew they're running all kinds of tests, his right arm starts to go. Soon after is when he went into a coma, and when he woke up is when he was completely paralyzed.
The stroke has changed my life in every way conceivable. Overnight, I went from being an overactive father of 4 and a chief financial officer to lying on my back all day. Luckily, I married a great wife. My family dynamics have changed with the Dynavox V. I can definitely assert myself more. Kids are kids though, and don't always listen.
All of a sudden, he's jumping in, being able to say, what part of no don't you understand? You know, come over here, do it again, and he'll follow him down the hall, and they can't ignore him.
I just think that's a great video clip to show how participation in his family and life just makes such a big difference for him. He's a chief financial officer, so obviously a very intelligent man. And can you imagine how depression might set in and him regress from being able to participate with his family and others had he not had this ability to communicate through a communication device? So pretty amazing that you can communicate with your eyes. And I should probably just, I'm taking up some people's time, but this is Stephen Hawking. How many have seen him on the news? Okay, so he has ALS and it's causing his muscles to decline in function. And so he activates his computer system through a sensor that rests next to his cheek. So right now the only muscle he can have consistent control of is this muscle in his cheek. So again, like Sarah was activating her device with her head switches, his device is doing the same thing and scanning and lighting up, and when he gets to the symbol that he wants, he tenses that muscle in his cheek and it reads that movement and activates the symbol. So pretty amazing. So we can find, you know, whatever your disability is, there's a way out there now for you to communicate, whether it's through eye gaze or tensing of a muscle or activating a switch. It's pretty amazing. And I'm sure things, I can't imagine where they're going to evolve from now, because that seems pretty amazing in itself, but I'm sure things are going to continue to evolve. Another new technology that's a really hot topic in the world of speech pathology right now is using the iPad for a variety of things, and they do have communication software or communication applications out there for the iPad now. So, you know, we have these very sophisticated, what we call dedicated devices that you can watch the videos on that are made solely for communication, and now we have, you know, iPads and Android tablets where anybody can make an application and they can use it for communication. So there's good things and bad things to the iPad. That's kind of a hot topic in speech pathology right now. It's a hot topic in terms of funding, because we do have to get these devices funded through insurance companies, Medicare, Medicaid, because they are very expensive. So like the eye gaze technology is about $15,000 by the time you buy the computerized system and the eye gaze system. If you just purchase a communication system on its own, if it's a dedicated one, it's about $8 grand. So they're really expensive when you pose that to families that, you know, can stress them out a little bit. But insurance has been great about funding, but now we've got this cheaper thing in the horizon that they're saying, okay, well, we could save, you know, $7,500 if we buy one of these. The problem is the research is not behind these devices. Anybody can design a communication app, and do they really take into account language development and the words that people need to communicate? They're not very durable. Who do you call if they don't work? There's a variety of other things, but very, very hot topic in the technology world. So that's my piece on AAC technology and speech pathology. I love working with individuals who are nonverbal because the power to communicate is amazing, and to be able to give that opportunity to people who can't do so is wonderful.
Thank you, Mrs. Becker. We have 2 more to hear from, so I'm going to let them keep going. We'll do questions at the end. I know this is fascinating. I wanted to give you the perspective of technology from the field of audiology, and this is what Dr. McNamara can give us. in terms of how this can affect your hearing and the tools they have today. So.
Okay, some things that I'm going to show you we actually have in our clinic, so I feel very fortunate. I can say that we have some of the best equipment, probably of many of the universities around, that we use for testing in our clinic. I'm going to talk about some technology advances in audiology in the area of our diagnostic equipment first. And in case some of you don't know audiology, we deal with the ears. Trina deals with the mouth, or the talking, and I deal with the ears, so we play that all together. But we do have a clinic that is open to the population, the general population, and we do hearing evaluations. Before, I did do some video clips, and this is a technology presentation, and my technology didn't work, surprisingly. But I was showing some videos of our old equipment that we had. And our old equipment, pretty much it was analog. It was very big, very heavy, and it wasn't portable. There wasn't much we could do with it. It sat in one place, and it was limited in the kinds of tests that it would do. Just this year, we were able to get this equipment, which is PC based, and now we have the ability to do multiple tests, and many of the tests that we utilize are on icons on our screen, and we can just go up here and click it, and there's tests that we can do to help assess tinnitus or ringing in the ears. Anybody experience that a little bit, tinnitus or ringing at times? This equipment also lets us assess what we call ultra high frequencies. When we do evaluations, we usually test in the pitch range where most speech sounds fall. However, when people start to experience hearing loss, their high frequencies go first. So we usually don't test much above the speech frequencies. However, this equipment now lets us test in the very, very high frequencies above the speech range, and we can start to document if somebody's hearing changes early. And this is real critical for people that are taking drugs that may be affecting their hearing, ototoxic drugs, those kind of things. And this equipment enables us to do this. Now, it's really funny because the old audiometer looks something like this. It was about 3 times that size, and students just cannot handle it. They looked at it and they saw the buttons, and that was it. They just shut down. It was very overwhelming for them. With the new equipment, we have a control panel that looks pretty similar to our old equipment, but the students now can operate everything with a mouse. So whatever they change on here can be changed on the screen by hitting icons with a mouse. And there's so much more at ease with a computer. It's just amazing. They are able to, I would say, it's more friendly to them. They feel much more comfortable with it. The best feature about this, you can see this actually is a window, and there's another, this is the booth where the individual set that we are testing, and here's where we set. Inside the other room, I can take whatever information I have on the screen and project it up on the screen in there. Also, we have that screen sitting 2 rooms down in what we call like a counseling room. So after I get done with my testing, I have all my information on the screen, which projects to another room where I can take a patient in and sit them down comfortably in a chair and be able to go over the test results with them. So before, everything we had to record manually. We had to make sure that it looked halfway professional when we finished our testing. And so we were doing all this paperwork, all this shuffling. Now we record our test results as we go along. It's on the screen. We take our patient into another room, we sit them down, we can show them everything that we did, and there's no time delay. So that's probably one of my favorite parts of this equipment. Another new feature that we have is called an admittance bridge. Again, if I could show you the picture of the one that we had before, I would say it was probably about this wide and this tall, very heavy. Now, this is the one we utilize in our clinic. This enables us to look and assess the middle ear status of an individual. Have you heard of people that have had fluid behind their eardrum, ear infections, and they went in, especially children frequently have those problems. They go in, they put a tube in the eardrum, it kind of lets the fluid out, it enables air to get into that middle air space, and that's how they treat it. With our new equipment, I did bring this just to show you that I wasn't lying, that we really did have this. With our new equipment, we can, this little admittance bridge does everything and more than what the old ones did. And it also can be interfaced with the PC. So we have a small screen here that shows our results when we run them on a client. And then we can set this in a cradle, and I have a picture of that in the next one. It can set in a cradle and then connect to a PC if we want to have a bigger screen. So what this does is this actually puts air pressure into the ear canal, and we check the flexibility or mobility of the eardrum, and we can see everything that's going on behind the eardrum. If there's fluid, if they have, if there's 3 small bones in there, if they have a break in this 3 small bones or whatever. So it really is helpful for us to decide where the hearing problem is what it does. Now, if I decide to stick this in my lab coat and take it across campus with me, in my other pocket, I can stick this little Bluetooth printer, and I can print out all my results from there. Also, what I can do is, I have a printer hooked up to my PC, so when I interface it with my PC, then I can make a larger copy if I like. This equipment will also interface with my big audiometer. So I can take my information that I have here and communicate with the audiometer and put all the results on one form. It's pretty exciting for an audiologist, I know. This is another piece of equipment that we have in our clinic. It's called a video otoscope. Now, how many of you went to the doctor and he's done the little otoscopic exam where he stuck the little otoscope in your ear and took a look, and you just kind of take for granted, or you take his word. Okay, oh, your ear looks good, oh, everything's fine in there. Well, what we have is now called a video otoscope. So we can look in a person's ear, and the image will pop up on our screen here. We also have this connected to a TV screen. So as we're looking in the person's ear, that individual can sit and actually look up on the screen and also see what you're looking at. So it's a great learning tool for our students, because as we're looking at things, I can pop it up on the screen and explain to them, but also it really helps when you're trying to explain to the client something that you see in their ear, like a tick. Actually saw a tick in somebody's ear one time. So we pulled it up on the screen, and there they could see. So it was kind of helpful. So this is a video otoscope. I just want to show you a picture here of what it looks like when you're looking in someone's ear. And this is the inside of the ear canal, and we're looking straight at the eardrum here. And that's what we're looking at. So we're actually looking down into their ear canal. We can see their eardrum here. This is what we call the cone of light. We look for that. That tells us it's a nice, healthy eardrum. You can see the outline of the first bone that's behind the tympanic membrane. And it's extremely useful, like I said, especially when you have to talk to a patient and tell them something that's going on in their ear, or if you're using it as training purposes with students. We also have what we call otoacoustic emissions testing in our clinic. And we take this instrument and we can hold it up to a person's ear, and it takes about 2 minutes for this to run. And it will actually tell us how well the inner hair cells in their cochlea are working. It's very important for us to know that, because it helps us to distinguish whether someone has a permanent sensory neural hearing loss. Have you heard of people that have permanent hearing losses and they have to wear hearing aids, that kind of thing? this gives us information how those outer hair cells are working. Usually when someone has a sensory neural hearing loss, one of the first things that will go is the outer hair cells. So this instrument will tell us the integrity of those outer hair cells, and it'll do it in like about 30 seconds. Another advance in our field of audiology has to do with what they call auditory brainstem response testing. What we do with this is we actually paste electrodes around a person's head, we put a sound in their ear, and we read brain waves of how they're perceiving that sound. So this is a picture of how I was trained. This is how we used to do this. We had to make sure that the individual was very still, because of muscle action, those kind of things would produce a lot of noise. Those electrodes would pick up that noise. So it was kind of difficult to do younger kids. It was very difficult to do babies. You either had to make sure that they were sleeping or napping, or you had to sedate them, okay? So what they have now is they have noise cancellation methods. Physics people understand that, where their ability to cancel out a lot of that noise. So you can actually have a baby sitting up in his mom's lap, wide awake, turning his head, and you can run auditory brainstem response on them. So it's very, very helpful and opens up the possibilities of testing a significant number of individuals, a lot of different populations than what we were able to do before. Okay, so I kind of talked a little bit about the advances in equipment, and most of that equipment we actually, like I said, have here in our clinic in the Communication Disorders and Sciences Department, which I feel very grateful that we do. I just wanted to just mention briefly a couple other advances in our field, and one of them has to do with the amplification. How many of you know somebody that wears a hearing aid? Okay, most everybody. What's real critical about this is they're doing lots of research now with young individuals. I think the study came out that they had completed, and they were checking from about age 17 to 23. And what they found is that hearing loss is on the rise by over 70%, because the iPods that students wear, it's directed right into their ear. Oftentimes it's very loud. So amplification is going to be a very critical issue when these individuals become older, because once you have a permanent hearing loss, as of now, there is nothing you can do except for consider a hearing aid. They have not been able to regenerate those hair cells that are killed off by the loud sounds. So essentially, if someone has a hearing loss and they want to hear better, and it's a permanent type sensory neural loss, they have to consider amplification. Up here shows the different types and models of hearing aids that we have. In the past, our hearing aids were mostly analog. They didn't have any digital components to them. However, almost all the hearing aids now are digital hearing aids. Some of them are a little bit hybrid still, where they might have some analog components with some digital in there, but a majority of the hearing aids are digital. And this is very important, because now when we bring an individual in and we fit them with a hearing aid, before we were very limited on how we could alter that hearing aid once they were in our clinic. What we do now is we take the individual and we set them down and we put the hearing aid in their ear and we hook it up to the computer, and we have a full range of changes we can do with that aid. So before, if someone received a new hearing aid and there wasn't quite something that they liked about it, or the sound quality wasn't really what they wanted, we may have had to send it back to the manufacturer to have them do these alterations. Now we just hook it up to the computer and we have a full range of those changes that we can make in the office now. Now as you look at these, this brand here is becoming the most popular, and you're kind of looking at that. Well, most people, you know, prefer to have something set in their ear that's less conspicuous, but they can make these behind the ear aids very, very tiny. And this individual here actually has one behind her ear. And what they'll do is they'll take the hearing aid and they'll make it a color to match their hair. And this little, what they call dome part here, actually has the microphone in it. So they separate the microphone from the receiver and you have less chance of that feedback. You know how when you listen to somebody talk and they get their microphone up too close to the speaker? Well, that's what they do. And there's all kinds of circuits now that help with listening and noise. It actually picks out the speech sounds and it enhances the speech sounds and suppresses the noise that's in the background. So if you know of anybody that's thinking about a hearing aid, maybe has a permanent type hearing loss, they are expensive, but digital is the way to go. So, okay. I just wanted to show this to you because I think that hearing aids have less stigma than what they used to. People are more accepting of them. So now you can get leopard print hearing aids. You can get multicolors, and it's very fun to see the little kids in the schools now because they come in and they'll have like purple hearing aids with tie-dyed ear molds with them, those kind of things. And you can even get a hearing aid for your American Girl doll. So I really, yeah, I appreciate this because I think people are becoming more comfortable with hearing aids, and it is a known fact that if you can't hear, you don't communicate effectively, and then you do experience problems with isolation, social problems, those kind of things. So it's nice that it is more accepting. And I just want to show this last really quick video about a cochlear implant, and then I'm going to tell you about a couple of the advances they've made in cochlear implantation.
The Maestro cochlear implant system was developed for individuals with severe to profound sensory neural hearing loss. The Maestro CI system consists of an audio processor, a small device worn behind the ear, and an implant which is surgically placed under the skin. The coil, which is connected to the audio processor, fits exactly over the implant and is held in place by magnetic attraction. Signals are sent from the audio processor to the implant via the coil. During the operation, the surgeon inserts an especially soft and flexible electrode array deep into the cochlea in order to stimulate a maximum number of nerve fibers. By inserting an electrode deep into the cochlea, the entire frequency range of the cochlea can be stimulated. The non-functioning part of the cochlea is bypassed and the sound signal is directly passed onto the hearing nerve. The microphone of the audio processor picks up the sound signals. The audio processor digitally analyzes and codes sound into a special pattern of coded electrical signals.
Okay, so I just kind of wanted to show you that real quick so you understood what they were doing when they did cochlear implants. Cochlear implants are for individuals who have very severe to profound hearing loss that do not have the ability to hear speech sounds even with the use of hearing aids. Now, the problem with cochlear implants is once they insert that electrode array into the cochlea, if you have any hair cells that are still functioning, it will kill them off, okay? Because the electrode wire was so big that once you inserted it in there, any hair cells that did still work would not work anymore. The cochlear implant took over. So it was really important that you made sure when you did a cochlear implant that that person didn't benefit from hearing aids. Because once the implant was in, that was done. That's the only thing you're going to be able to use. Now they have developed a very, very thin electrode wire. So what they can do is they can go in and insert that electrode wire. If you still have some residual hearing, if you have some hearing in there, you have some of those hair cells that are still functioning, it won't injure them. So one thing that people didn't understand was once somebody took off their cochlear implant, their ear was completely dead. Now that's not so true, okay? They're just starting with these implants, so you probably won't see this become real prominent for a few more years. But with the invention of the new wire, what will happen is once the person takes the cochlear implant off, they still may have some residual hearing. So maybe they might stick on a hearing aid. They won't hear as well as with the cochlear implant, but they'll still hear something. If we have a child that has a cochlear implant, now if their implant doesn't work, their ear is dead. They don't pick up anything. So that's been a huge advancement in this area. Also, what they're doing with cochlear implants is they've just developed a way to do what they call a hybrid. Now, some people will have some hearing in the low frequencies. That amplification may help, but then they have a significant drop in the high frequencies or the high pitches. Before, if they did a cochlear implant, you were going to wipe out any hearing that they had in the lows, and then they would totally rely on the cochlear implant. Now, what they're doing is they're inserting the cochlear implant so that the person can use their hearing in the low frequencies, and the implant will actually just kind of amplify that, and then the implant itself takes over in the high frequencies. So they call it kind of a hybrid, because they're still using like a hearing aid to help with the low frequencies, but the implant is taking over the high frequencies and making those sounds audible. So with those kind of advances, it's really, I think you're going to see more and more people who have significant hearing losses go with the cochlear implant, because they know that even without the implant, they'll still have some of their residual hearing, and they can go back to using a hearing aid if needed to at any time. So those are some of the advances that are going on in our field, and of course I'm kind of biased, but I think that it's extremely interesting, and every day I just pick up one of our journals and read some of the things that they're doing. So that's it. So I'm going to give it back to you.
Thank you so much. Dr. Rebecca Thornburg is going to take us home, and I've asked her to talk about some advances in overall management and education in the field that I'm really proud of the department here for implementing.
Okay, so Dr. Augustine asked me to talk about a little bit of about some of the technology that we use overall. We're using it in our clinic now, and we are also using it, and people across the country are using digital for file sharing and clinical records. We hear, you see the doctor come into the waiting room with the iPads and accessing clinical records and such that way. We are doing that also in EIU speech language hearing clinic. We used to just have a paper file system. Now we have two different ways to access our files. We have on base for kind of historical storing of records and files, and then we also use Zythos and Panther File for secure sharing of our weekly plans and drafts of reports between the faculty members and the student clinicians. In the past, we also recorded all of our sessions using videotape, and we had a big cabinet with VCR, VHS tapes, and that's the only way the clinicians could review their tapes. Now we have a digital system that people can watch from their laptops. We've used the new technology to enhance our education of our current graduate students. I guess one thing I'd like to mention also, though, is the same type of web-based communication is working in our field also for shortages. So in places like in rural school systems, like whenever they can't get an SLP to travel to a rural school that just has 2 people on the caseload in Southern Illinois, people are using Skype, people are using other web conferencing technologies to actually provide distance services. So we're seeing people with specialty areas actually providing assessment and treatment, and again, there's evidence in our field for it can almost equal effectiveness in many ways, that you're getting an expert person to do a diagnosis, and you're not having to get on an airplane to travel to California or New York to get that diagnosis done. So again, that's so the web conferencing will change our field as we're doing some distance assessment and treatment, and we are also then using that to train our future professionals. So when we looked at our program and tried to think about how can we replicate what we do in-house for our training program, and how might we do a similar thing for students at a distance, what can we do the same, and what would they need to be on campus for. So we studied our whole graduate program, and we looked at, again, there are certain things that our students are going to come back for face-to-face interactions on. Like Trina's AAC technology, we really can't put those AAC devices in their hands when they're further away. And actually, Tina's audiology testing they're also doing when they're on campus, because that equipment is so expensive and they need to run that computer system when they're here on campus. But many of our other courses in the graduate program, we figured out ways to try to get a very similar experience using distance technologies. So some of the main philosophies of our distance program that is similar to our residential program is that we will have as much interaction with the professor and other students. Sometimes when people think about distance education, they think about it being a self-study. I'm isolated, I'm by my home, I'm teaching myself, I'm just logging in for my quizzes and things, and our distance program using technology is very interactive, both with the professors and with the other students in their group. We are trying to make sure that they have the same experiences. So our traditional program courses are recorded, and then we stream them, and then we use Blackboard Collaborate, which allows us to have live interaction, which I'll show you in a second. So this is a picture of our classroom. We have a digital camera in the back of our classroom now that we're very happy with the quality. The first year we tried some piloting with Panopto and web cameras, and the quality just wasn't there. It didn't work reliably, the sound wasn't there. It caused a lot of problems, and we really weren't ready to kind of launch a distance program until we had better technology. Now we've got a digital camera and a different ISR recording system, and it really does give you just a view like you're in the back of the classroom. So our distance students who are out working full-time during the 9 months of the schools, they hear and see the same thing that our traditional students do sitting in the classroom. So here's a brief clip of Dr. Richard, our department chair, teaching in the classroom. And so you can see how the students at home can view and hear the same things that the people in the classroom are seeing.
All right, so pragmatic language. How many of you worked with clients on pragmatic? You've worked autism, you've worked pragmatic. You worked with adults, with aphasia, TBI, you've worked pragmatic. Asperger's, certainly you've worked pragmatic, but even processing.
When I taught distance classes about 5 years ago, I recorded lectures for the distance people. And there's a difference when you record a lecture. I'm talking to myself, I'm in a room, I've got my PowerPoint, I'm talking to myself, no one's there to answer, no one's there to look confused, you don't have that same kind of feedback. But now when we're recording live classes, those distance students are getting a very different experience. They are hearing the questions that the traditional students are asking, the responses that the faculty are getting. The faculty are showing video clips, they're showing demonstrations. So that digital camera in the back of the room can also zoom, and we're getting better over time at using those zoom functions and such. So we can zoom in when a video clip is showed, we can zoom in to a different screen when an object is shown. And again, we get, we do a lot of not just pure lecture. It's case-based type of discussion. It's let me ask you a question. Let me follow up with your thinking on that. How, your thinking was off there. Let's follow a line of questioning this direction then. So students hear all that. I mean, there's a very big difference when we record a live classroom session compared to when we record a lecture, and what we are hoping our graduate students get from that. So again, our recordings now are in the back. It's like a seat in the back of the class. And it's neat too, like I said, 'cause this is our second year of our distance program. Our faculty are starting to teach to those distance students too. So they're sitting there in the classroom and they're saying, okay, to the students that are sitting there, they're saying, let's ask these questions, let's ask these questions. Then we have live meetings with them in Blackboard Collaborate. And so a lot of times the instructors now will look up at the camera and say, cohort students, you know, you be ready for this on Monday night. Or cohort students, remember, we talked about this last Monday. This pertains to the question you had. So even in the live classrooms, they're talking, our faculty now are starting to talk to the people in front of them, but then they're also keeping in mind, hey, there's another group of 15 students out there that I know and I'm talking to, and I'm gonna tailor my comments to them as well. So that digital recording of classroom of the live classroom has been very valuable. The other piece of it that has been critical is Blackboard Collaborate, and we use that for synchronous discussions. So Monday nights we get together then with our 15 cohort students, and I have not, knock on wood, I guess the one thing we're having problems with is live video. Exactly the same. And up to this, we're gonna figure that out yet. Because up to that point, everything we can do in the classroom, we've been able to do in this Blackboard Collaborate. You know, we show, you can pull up PowerPoint, you can share your desktop. So this is a PowerPoint presentation. I have my 15 distance cohort students in there. Those 15 distance cohort students can raise their hand. They can pick an icon that shows confusion. They can turn their microphone on and ask me a question that I can verbally respond to. They can type their questions in here and I can watch that. They can also go into small group rooms and they can share their computer with each other. So again, I taught a research class in the spring, and so a lot of times what I did in the face-to-face classroom was, you know, they're in peers working on planning a research project, and so I usually spend about half of the class floating around the room answering individual questions, looking at their computer with them, looking at their project, looking at their data, looking at their research articles, and asking them and helping them with their questions. And I also have then meetings with the face-to-face students. So we were able to replicate this whole thing, the same thing when we did on this distance. We can put them in breakout rooms. So we can put 2 students in a breakout room. They can work on their paper. They can share their computer with each other. So we had a student in Indiana, a student in Wisconsin. They go into this room. There's 2 of them working on it. They're sharing their computer. They're turning on their microphones. They're talking and looking at the same thing on their computer. And then I can browse through and talk to each pair. And then I can say, okay, time's up. Let's all go back to the big room again, and we'll work together on our project. So it's pretty neat. Let me just show you this real quick.
I want to show you a little bit.
A recorded demo. So we can do things like this too, that basically just shows you everything I just said.
So questions? I think you guys can take a shot at putting some slides together. Yes, Susan?
Okay, if we're putting slides together, but we don't have all the data collected yet, is it just the draft of work in progress? Is that what you're looking for?
Okay, so that was Susan. Susan was sitting there. She said, I've got a question. So she raised her hand, and I said, yes, Susan. Susan turns her microphone on, and she said, yeah, so we have a discussion about that. Then,
Yep. Up to this point, that's fine. Like I think, yeah, you'll keep adding to.
then another student typed a question at the bottom. I saw that. I was able to respond to that. And again, it's allowed us. I mean, we're a pretty perfectionistic group in our department, and it's allowed us to find ways to teach very, very similarly. And we hope we have the same types of outcomes as we've had with our traditional face-to-face programs. So that would be the end of my part.
Well, would you join me in thanking my colleagues for presenting this morning? I've always been part of the Department of Communication, Source, and Sciences, and you can see that we're fortunate to have this incredibly dynamic group of faculty who stay on top of current technologies, and an incredibly supportive administration that ensures that they have access to the resources that they need to continue to provide the technologies that are necessary. Can you imagine how people in our region benefit from this incredible clinic here? What you can find here in our region is the gemstones of access. I know I speak from personal experience as my mother-in-law in her 60s came down with something called progressive aphasia, which was the loss of her ability to speak over time. And thank goodness I had colleagues who knew about AAC devices so that she could continue to communicate and be a part of her family as she lost her ability to speak. And of course, my dad, a World War II veteran, who was active in the military and never wore hearing protection, is quite hearing impaired today as a result of all that loud banging, and I'm so grateful that I know people who can help guide him to hearing aids that help him to continue to participate and hear and such. And we're also grateful. I just was invited to Budapest, Hungary, where I presented exactly what Becky just presented on a model for online education for comprehensive universities across the globe, not just in Illinois, not just in the Midwest, but across the globe. And so they have a regional, state, national, and international footprint here from this university. And so I'm so grateful to all of you, especially for presenting today. I could have never have presented this information the same way that you could. So thank you very much. Maybe you have one or two questions.
Any questions? I have one or two. So anybody starts or I start? Now, is it true, the popular knowledge that, or idea that when a child has hear impairment in growing up, he will definitely, quote unquote, have speech impairment as well?
It depends on how the hearing impairment was treated. And with those cochlear implants, the FDA's regulation says that children 12 months of age can be implanted. And what they're doing is they're actually doing waivers. Carl in Champaign, the youngest that they have implanted is 7 months. What they're seeing with the majority of these kids is they are progressing with normal speech and language skills. A lot of them. Now, not all kids that have cochlear implants take to the auditory information that most do. There are still some that are very visual learners. But it really depends on how early their hearing loss was detected, how it was treated, those kind of things, how severe it is. For example, we have a child over in the school here that we work with. One of the things we do with our students is we do take them out and we provide services to the hearing impaired children in the local Charleston school district. And we have one child that has had a cochlear implant when she was like maybe a little bit over a year of age, and she still is not an auditory learner. I have another child that's had a cochlear implant about the same time, and you wouldn't be able to tell that she ever had a hearing impairment. So a majority, though, of the children with cochlear implants are developing normal speech and language. The one thing that's interesting about that, though, is they're doing some very 10-year longitudinal studies, and they're finding that the kids with cochlear implants still lag behind their peers in reading. So there's some areas that we still need to work on.
Now, as a child, I was maybe 6, 7, 8 when they brought Helen Keller in Blood and Flesh in our school, American school in Alexandria, Egypt. I still feel the thrill here. And how could she do that in the age? I mean, it was in 1800 something. How could she overcome this? Especially, she was not treated, I guess.
Exactly. You know, unfortunately, intellectual ability plays a lot in that too. Mm-hmm. She had to be a very, very bright person that was just kind of held in because of her hearing and vision disability. And once she found avenues that she could communicate, then she was able to compensate really well for that. So, you know, I mean, you can provide kids with all types of services, but they have to have that intellectual ability to take those services or take those communication modalities that you give with them and run with them, you know, and be able to flourish.
Now, last question before I give the floor other questions. Why is it there's big disparity between $3,000 a piece and $30 a piece as you see it on TV?
Oh, yeah, that's a real sore spot with us. Because first of all, the one little hearing aids that you're going to order off the TV are not going to be digital. And second of all, they're not going to be specifically fit for your degree and type of loss. That's the one thing that we do as audiologists. we put you through extensive tests so we know exactly how much hearing loss you have at each pitch range and how that's going to affect the different sounds or speech sounds you're listening for. So then we take a hearing aid and we will take your hearing loss and your specific information that we get and hook it up to the hearing aid in your ear, and we'll match that hearing aid to fit exactly each frequency or each pitch range that you need and how much loudness you need at that level. And that's what the digital does for you. So you're getting, it's like going to, it's like not having a vision exam and going to Walgreens and trying to figure out what kind of glasses you need, or go to the doctor, get your true prescription, and then fit it exactly.
$30, $33.
We are really having issues with that because there's lots of online sources now where they say you can order hearing aids. Another thing we do is, especially with some of those hearing aids, even the ones behind the ear, you have custom molds that fit into your ear. So we make everything to custom fit you. And if you order them online, they're not custom fit. So, it's kind of a one-size-fits-all deal, but you're not going to get the quality at all.
Well, any other questions to our distinguished panel?
I'm sorry.
No, it's okay.
When you were talking about the expensive equipment that you felt the students needed to come to campus, brought to mind the opening speaker, Bob Ehrman, and they have the same situation in nanotechnology at Penn State, and they're using a software that was rather inexpensive, where they can turn because the equipment that they use to examine the pieces of nanotechnology is very expensive, they can turn the control over to the satellite site, and they can control that. They have the same features on their computer screen, and they can manipulate, zoom in, zoom out. And I was saying, oh wow, you should check that out, because that would be something else that
I could see that in audiology, because our new audiometer is PC based, and we're in the process now of bringing in Ethernet to hook it up so it can. And if someone just needs to write the software that would go with that program, you could manipulate everything on the equipment. I could definitely see that.
You need to contact him.
Yeah.
You need to contact him, because
I need to develop the software and make $1 million.
Well, your software, your software is already in place, and what you're doing is through this one particular software package. All they had to do, he said it's free, is that?
I think so.
It was free, the users, it was free, and, but then they could go in and control the zoom in, the location of, they can measure the pieces that they've located when they zoom in on that, like, I don't remember how many times. So they can go in and measure that and then record their data at their desk. But it was all through that particular software, and it was the same comments that you made, was the equipment's very expensive. So they were having to have students come to campus for the program, but now they're out reaching out to campuses across the United States, wanting to start this certificate program, and it will be through.
I think our biggest difference with that, though, is we're actually dealing with real people when we're manipulating our equipment. So if I have someone that's manipulating it off campus, they're not really interacting with the person that they're testing, which may be kind of hard. But I could definitely see that being able to be shared. Absolutely.
Yeah, and you have a good point that you really need to be at the same place. However, that's something that could give everyone a little taste of what's possible when you're going to go. EIU has that stuff.
Well, I think you agree with me that the topic is interesting, and that Dr. Bob Augustine is a contagious person. He is as interesting, and his speakers as interesting. So please join me in thanking them. And